Hello, this is going to be a walkthrough through the Spring 2016 retake midterm. Alright, so the first question we have is what would Python print question? We see here that we're given this function definition, and so we can go into the problem now. So the first problem, we define this function called mu, and we call it. So this is going to be x, y, and z. So we know here that x is going to be 9, y is going to be 3, and then z is going to be 2. So we see that this is going to be 6, and we're going to divide by 2. It's going to give us 3. Next, we're going to define zoo and call zoo. Again, x, y, z. X here is 13, z is 6. So, and we know y. Y is going to be 2, but we see that x here is going to be changing. So why don't we keep track of what x is? So we're going to keep iterating as long as x is greater than, as long as x is greater than z. So in this first loop, we see that x is 13. Then after the first loop, x is going to be 11, and then x is going to be 9 after that the next loop, and then 7, and then when 7 hits, we're still going to be greater than 6, so we're going to do that loop. X is going to be decremented to 5, and then we're going to check again against, is 5 greater than 6? No, so we're just going to return x, which is 5. Cool, so next problem, we have this f function, and then we use sp16, and that's given up here. So in this problem, we're going to be passing in this as sequence and this as fun. So I'm going to be kind of applying this f onto a sliced version of sequence. So if we kind of look at this at a very high level, right, what all that f is doing is giving me the first element that I have in S. And S is always going to be the sliced list depending on what depending on I. And I is just going to be simply length of list, which is 1, 2, 3, 4, 5. So range of 5 is going to give us 0, 1, 2, 3, 4. Right? So we know we're going to be slicing from 0, and then from 1, and then from 2. So essentially it's going to be looking like this, and then like this, and like this. So my list is going to continually get smaller, and then in each of those lists, I'm only going to take the 0th index from it, right? So if you take the 0th index from the first one, it's going to be 1, and then the 0th index from the second list, which is 2, the third list, 3. So I'm essentially just going to copy over my list, and just a very complicated way to copy over my list. Cool. So now we're going to redefine what f is, and then we're going to have pass in the same sequence and the new f into sp16. And so if we look back up here, our f has now changed. So what does our new f do? So x is going to be assigned to the 0th element of the list, which is essentially what we were doing in the previous problem, and we're checking if x is greater than I. So anytime, and then if it is greater than I, I'm going to return x, else I'm going to return the index, right? Because what is I? I is essentially giving me the index, or it's essentially saying if I have a first element that's greater than whatever index it's at, then I'll just return that element, else I'm going to return the index, right? So why don't we look at our sequence now? So our sequence is 1, 2, 3, 4, 1, 2, 3, 5, 10. And so for this position, the index is 0. This position, the index is 1, 2, 3, 4, right? So now we're going to just check. So for 1 and 0, which one's greater? We know that 1, which is the x, this is x. The 1's greater, right? And then for 2 and 1, we see that 2 is greater, 3 and 2, 3 is greater, 3 and 5, 5 is greater, and then 10 and 4, 10 is greater. So there's no position in this list where the number is less than its index. So we're just basically copying over our list again. Cool. So now we again redefine f, and then we're passing a new sequence to f, or seqfun, and basically applying that that function. So here, I'll copy this down so it's easier to see. Okay, cool. So in this, I'm going to be doing an OR. I'm going to be saying I OR the 0th element of S, which remember, it's again like this first problem we did, where it's basically just going to get every single element from sequence. And so when I'm doing OR statements, remember that OR statements short circuit when the first time we hit a true statement or truthy value. So we know I again is going to be this range. So it's going to be 0, 1, 2, 3, right? Because the length of our list is 4. So we see here that we're going to start I is going to start out to be 0. And then so 0 is actually the one falsy value that we have. So in this first iteration of our list comprehension, 0 is going to be false. So we're going to then move on to S0. And we're going to check if S0 is true. And S0 here we see as 2 because we're still in the first iteration of our loop, or of our list comprehension. So we're going to give it 2 because 2 is not a falsy value. Cool. So now we're moving on to the next part of the next step of the list comprehension. So our I is going to be 1, and our S0 is going to be 3. So 1 is actually a truthy value. So we can just short circuit there. We can stop the OR, and then we can just give 1. Same with the 2, and same with the 3, because none of those values are falsy. Cool. So now here we redefine f as just returning the list. And remember, our list is always just like this list that gets decremented each time, right? So if we look here, if we have sequence as 1, 2, 3, 4, what's going to look like in the next kind of step, because since I is always increasing, right, we're always going to be slicing higher up our list. So when I is 1, it's going to be 2, 3, 4. When I is 2, it's going to be 3, 4. And when I is 4, or 3, sorry, it's going to be just 4. Or sorry. So this is when I is 0, I is 1, I is 2, I is 3. Right. And so that's essentially what our f is returning, right? It's going to be just returning s, because it's going to be s, s, and s, and s each time, because that's what we're passing in here into our function, right? So since we're returning lists each time, right, because this s here is a list, we're going to have a nested list, right? We're going to have a nested list of 1, 2, 3, 4, and then 2, 3, 4, and then 3, 4, and then 4. Cool. So now moving on. Now we have a higher order function here, right? So we see that we pass an f of 3. So f of 3 returns us g. So then we have to take an s and I like we usually do. The s is going to be this list, but sliced according to I. So let's see what this is doing. So if we're slicing it from here, Alright, so we don't really care about the list anymore, right? Because we see that in our return statement, we only care about x, which is always going to be 3, and then I, which is always going to keep incrementing up each time. Right? So the length of our list is 4, so we're going to go from 0, 1, 2, 3 for our range. And so these are going to be all the values of I, right? So we can just add 3 onto each of those, essentially, because x is never going to change. So it's going to be 3, 4, 5, 6. Now, finally, on the last problem, for this last problem, so we can see that we're kind of looping through, however, like our sliced list, right? And then here we probably have some total, and then we're going to return it. And so remember how our list is going to be sliced, right? So it starts out as 2, 3, 4, 5. Then it's going to be 3, 4, 5. Then 4, 5. And then 4. Right. So this is what this part of. So this is going to be what this is going to be each time as I increases. And so let's see what happens in F. So in F, all we're doing is summing over whatever list we're passed in, right? Because we're going, for each x in S, we're going to add that x onto P, and P is our total. And so this is going to add if you add all the elements up together, this is going to give you 14. This is going to give you 12. And then this is going to give you 9. And this is going to give you 4. Oh, wait, sorry. This shouldn't be 4. This should be 5. So this will give you 5. Right. Cool. So since we know that these are all of our sums, we can just put all of these into our list. And this is what we're going to get.